Since even before the dawn of industrial society, human civilization has been built on the collective labor of billions of people over thousands of years. People have worked hard and in many unfortunate cases lost their lives in support of the status quo. Whether it be assembling products, serving others, constructing buildings, or anything else, our society has been built on the notion that people have to work. Now, however, with the advents of AI and humanoid robotics, we are approaching a fundamental shift in the human relationship with work that could dwarf the printing press, cotton gin, and industrial loom combined. While all of those inventions were ultimately groundbreaking, all they did was make human work easier. This new fleet of humanoid robots could actually replace the need for human labor altogether. At the center of this growing field is one unlikely competitor, Tesla. For a while now, Tesla has been far more than just a car company, and their rapid advancement in robotics and artificial intelligence has been amazing to see. The advantages that Tesla has are far more than just technological, however. Tesla is a huge logistics and industrial empire that has the means to not just build a sophisticated robot, but to scale it to the degree that will be necessary to change the world. Today we're going to discuss Tesla's plans in the growing field of humanoid robotics and their plans to eventually build a new robot every 30 seconds. With all of that in mind, let's get into it. To start, let's give a brief overview of Tesla's history with robotics and how we got to where we are now, before diving deeper into the future. Over the years, there have been a ton of companies across the world that have been working on designing humanoid robots. Honda showed off Osimo back in 2000. Boston Dynamics unveiled the earliest Atlas prototypes over a decade ago, and Amazon has already started using humanoid robots from companies like Digit to streamline their warehouses. In the grand scheme of things, Tesla is an extremely recent entrant to this field, and a lot of people didn't have much faith that they would be able to catch up. Tesla first unveiled their humanoid robot aspirations back in 2021 at their AI Day event. At the time, details were sparse, and the fact that they opened up this topic by having a person come out on stage dancing in a spandex robot suit made a lot of people feel like this was more of a joke than a real plan. Still, they went on to explain roughly how the robot would work, how they would utilize their existing FSD computers to power the bot, and then they promised a working prototype in a year. Tesla kept their promise, and by the following AI Day, they had developed a very rudimentary model that could slowly walk and do very simple tasks, as well as another prototype that had to be wheeled out on stage. This prototype was very simple in a lot of ways, but it did show that Tesla was serious about making robots, and that they were able to get a functional model working very quickly. Behind the scenes, development continued on the hardware and software that powered the robot that would eventually be named Optimus. As it advanced, we saw a lot of Optimus robots walking around the factory, balancing on one foot, and sorting objects using its onboard visual sensors. With each update, we saw Optimus growing more and more advanced and capable. Its second generation had a more polished appearance, finer motor controls, and greater dexterity. In less than 3 years, Tesla went from a person dancing on stage in a skin suit to a fully featured robot that gets better and better with each iteration. So what is it about Tesla robots that have allowed them to advance so rapidly, and even start to surpass some competition that has been around for longer? As I mentioned earlier, Tesla has been working on developing themselves into far more than just a car manufacturer, but rather a general tech and AI company. Clearly, they are working on a lineup of robots, but also artificial intelligence systems that power Optimus and their self-driving features in their vehicles. Optimus operates using the same cameras and processors that power the full self-driving system in their vehicles. That data is processed through the overarching AI system in their end-to-end neural networks, effectively allowing Optimus to learn as it goes, just like their cars do in large, massive fleets. The goal is that it doesn't need to be extensively pre-programmed on every little movement or action, like how most robots have required in the past. For example, Tesla has large, elaborate motion capture systems that capture tons of data on how certain tasks are performed. That data is ingested into the neural network, and it teaches Optimus how to do those tasks. As the system collects data from other humans, and from actually doing the tasks itself, Optimus will get better over time. In one video, we even see Optimus autonomously assess and recover from an error made while sorting battery cells into a tray. Once it recognizes that the cell didn't fit properly, it stops and fixes it, just like how a human would. In another video, we see Optimus navigating autonomously through the Tesla Design Lab, building a detailed map of its surroundings using data collected from multiple units throughout the factory. This is a perfect example of how Optimus learns very rapidly from completing tasks, and how multiple bots working in tandem helps them learn even faster. In another recent video, we see that Optimus has been equipped with a brand new hand, designed with greater dexterity and fine motor control. In this demo, Optimus was quick enough to track a tennis ball that was thrown to it and able to catch it out of the air. It was later clarified that this bot was being remotely controlled by a human operator in this clip, and that they were simply testing the actuation and sensors. Elon Musk did elaborate that it would be a, quote, easy move to connect AI vision with arm actuation to catch autonomously. Will be done next quarter. Even with Elon time, if that comes next year, that's very impressive. Even though Optimus isn't doing this autonomously yet, from a mechanical design perspective, this is very impressive. It's a major step towards Optimus reaching full parity with human capabilities and eventually exceeding us. This is all extremely impressive technology, but thus far, it is yet to be fully proven on a mass scale. The technology is still a bit too young and a bit too expensive to really replace humans en masse, but if it keeps growing as it has been, it won't be too long until that day really comes. Tesla has huge plans for their future of robotics production, and if their predictions come true, then their output capacity will be truly astounding. Elon Musk, whether you agree or disagree with him, has some big ideas for the future of the world, and his takes on humanoid robotics are perhaps his boldest by far. He has talked a lot about how eventually manufacturing robots will grow to become a bigger business than even their car manufacturing. At this point, there's no telling how exactly this will progress, but it has the potential to fundamentally shift our relationship with work, and any company that cracks that secret first would become bigger than we could really grasp. During a recent shareholder meeting, he went into a lot of detail about the ways that he sees robotics advancing going forward, and what impact that would have on Tesla. Of course, Elon Musk's predictions are often very optimistic to say the least, so take all of these numbers with a grain of salt. But even if a fraction of this comes true, that would be a game changer for the entire world. As these robots continue to become more and more advanced, he expects that relatively soon they will be able to handle any task that a human could do. That includes high-intensity factory work, all the way down to simple domestic tasks around the house or yard. Eventually, he suspects that they will be so useful and versatile that every human being on Earth is going to want to have one. Production might be so high that he expects robots will outnumber humans by as much as 2 to 1, with a population in the tens of billions. In order to meet that demand, Elon believes that the market will have to grow to produce in the order of 1 billion units per year. If Tesla were to capture just 10% of that market share, that would equate to 100 million units in production annually, the same number of cars that the entire auto industry produces in an entire year right now. That volume of units seems almost impossible to believe at a glance. It would require an industrial mobilization the likes of which we've never really seen before. Before that happens, though, if it were to reach that level, Elon has talked about Tesla approaching a, quote, million units plus per year level. That is much more reasonable sounding, at least for the near future, than having to produce 100 million units in a single year. Even still, this is a really remarkable goal, and if we break it down even further, it shows how remarkable even this level of buildup will be. So for the sake of argument, let's take it at face value that within a decade, Tesla may be producing 1 million Optimus robots in a single year. That's already an optimistic view, but in Elon Musk's mind, it's probably the pessimistic view. In any case, they'd be producing those throughout the year, and there are 525,600 minutes in a year. Put into minutes, that would require Tesla to make the equivalent of about 1.9 robots per minute. Put another way, Tesla hopes to produce one Optimus humanoid robot every 30 seconds. Production of these robots will spread across the world as demand grows, and dedicated factories will pop up that solely produce humanoid robots. 1 million units per year is already a very ambitious goal for the near future, but as I mentioned earlier, Elon has plans to produce upwards of 100 million in a year. If that comes to fruition, that means instead of one robot every 30 seconds, it will be 100 robots, or put differently, one robot every 0.3 seconds. That sounds absolutely insane when you put it like that, but this supposed growth is based on future technologies and industrialization, the likes of which we have never seen. That number may not ever come, and if it does, it's going to be a long way in the future. One thing is for certain, however, building robots is going to be a huge endeavor that will require massive industrial pushes to achieve. The other thing that's important to note is that you aren't going to see the production process of a robot actually take 0.3 seconds. You'll see Tesla finishing production on one every 0.3 seconds if they reach those crazy numbers, but that will likely take days when considering the progression from raw materials through the entire process. But multiple factories with multiple assembly lines producing the same product all at the same time makes this possible. Tesla similarly produces a new car about every 30 seconds, but it's in the same fashion, spread out across multiple assembly lines, across 5 different vehicle models at 4 different factories, with the entire supply chain in motion well in advance of final assembly. In some ways, it's hard to speculate on the eventual mass production of these units because of how unique they are in the grand scheme of consumer products. While Tesla makes very groundbreaking cars, at the end of the day, they share a lot in common with traditional car manufacturing processes and are built from that same foundation. They have already changed quite a few things, like their gigacasting, which simplifies the casting process by a lot, and into the future they plan to have an unboxed assembly process for certain cars like the Robotaxi. But Optimus robots are a completely new paradigm that exists only in small quantities as early prototypes. When Tesla first began to design the Optimus robot, they found that they could not rely on many manufacturers that produced off-the-shelf parts that they could use. Instead, Tesla had to design a lot of Optimus's components from scratch. While the company has a huge slate of very talented engineers who were up to the challenge, it still means that these robots will require a lot of very intricate and special tooling in order to be produced. Since they won't rely on outside vendors, this is a great opportunity for Tesla to vertically integrate large parts of Optimus's production from the get-go. As such, it means a lot of care has to be put into its design. In a recent post on X, Elon Musk himself noted the difficulties that come with designing a robot like Optimus for mass production. He said, quote, "The toughest part by far is improving the design of Optimus for ease of manufacturing and tooling up a complex supply chain, so it can be made in significant numbers." Even this early in the prototyping stages, Tesla is taking great care to ensure that when Optimus is ready, they will be able to start producing it as efficiently as possible. As these robots start to become more capable and ready to be incorporated into the economy in a major way, then mass production capability is going to be the name of the game. There's really no point in making this robot if not for mass production in their minds. A handful of advanced robots in and of itself is very impressive, but in order to have the desired impact, companies like Tesla will have to dedicate a lot of resources towards building them at scale. Of all the companies that we have seen pursuing humanoid robots, Tesla seems to be the most uniquely equipped to actually mass produce them. As a major automaker, Tesla has a lot of experience with producing large, complicated machines at wide scale. Some of the other startups that are out there right now may be able to make extremely impressive robot demos, but without some big production power behind them, it will be extremely difficult for them to make many units, and they will naturally be very expensive too. One of the great benefits of mass production is building economies of scale up over time, which drives prices down. These low production costs are going to be essential for mass adoption and for Tesla to sell them at the prices that they eventually intend. Take, for example, the electric car in the United States right now. Tesla is the only one that has figured out how to make this profitable in the United States. Every other company that sells EVs in the US right now loses money on their cars. So the same kind of concept is expected to be applied here. Once they get production fully ramped up, Elon has estimated that some future iterations of the Optimus robot would be producible for just $10,000 per unit. From there, they could go on sale for as little as $20,000. If we were to take his 100 million unit production estimate at face value, then that would mean Tesla would be making $1 trillion in profit on their humanoid robots alone. Based on those numbers, Elon estimates that Tesla's market cap will increase by approximately $25 trillion, with an additional $5 to $7 trillion coming from their autonomous driving technology and robotaxis. If that were to pan out, Tesla would become worth approximately 10 times more than the current most valuable company in the world at about $3.4 trillion. While selling these bots at $20,000 is the end goal, it's likely going to be a while before we see these bots up for sale at those prices. In the earliest days, prices will be considerably higher, as we see with most Tesla products. I mean, just look at the Cybertruck right now. And costs will be brought down as the manufacturing scale increases. In a recent post on X, Elon Musk wrote that eventually the Cybercab and Optimus would be purchasable together for $60,000, but that they would both need to reach production volumes of greater than 1 million units per year. It will likely be a while before Tesla can produce that many units in a single year, and then will be even longer until it reaches volumes that bring prices down to just $20,000. One added benefit that will likely come with future autonomous robot production is the fact that eventually those robots themselves will be used in the production process. As of earlier this year, Tesla has already slotted 2 Optimus robots into the production lines at one of their factories. These bots are stationed at the end of line where they grab finished battery cells and place them into a crate for transportation. Of course, this isn't a particularly difficult task by any means, but it's relatively early in their development, and these robots are already being put to work in a tangible, useful way. As their design and AI systems improve, they'll eventually be able to handle more complex tasks. For example, in a recent video update, Tesla showed off that Optimus can now balance itself and carry that large battery cell crate without overheating. In the same video, they also showed off that these bots can now autonomously navigate themselves to a charging station when low on battery, dock themselves, and then go back to work once they are fully charged. This is a great insight into what the future of humanoid robots in the workplace will look like. Robots like Optimus have very little downtime compared to human workers, and save for short charge breaks, they will effectively be able to work 24/7. In the near future, Optimus may be able to handle any task after only a very short learning period. According to Elon Musk's vision here, soon the bots will be able to effectively take over a task after just a short demonstration, and someday, maybe even just after watching a video. If their capabilities continue to grow at the same exponential rate, it might not be long before their roles in the factory start to grow. As I mentioned earlier, Tesla has already put 2 test units to work in their factories, but they have plans to start ramping that up very soon. By the end of next year, Elon bets that the company will have over 1,000 robots working in their factories around the world. And even if they miss that goal by 1 or 2 years, that's very impressive. He didn't elaborate on exactly what these robots would be doing, but given their versatile design, they could probably be slotted into a lot of different jobs across the production line. As their numbers increase, they will be collecting more data that will be used to train them further, which will help them to perform their jobs even more efficiently. As with most AI technology, it's one of those things where at first, it will actually probably slow things down and be frustrating on the assembly line, but in time will be much more efficient and much quicker at tasks we see performed today. Again, it's best to treat any specific numbers and timelines with a lot of skepticism, but the overarching point here is undeniably, these robots are coming, and they are coming fast, from Tesla and other companies. While robots like these could eventually reshape the entire economy, in the relative short term, they are going to do a lot to revolutionize Tesla's business model in particular. For example, slotting Optimus units into their production lines could do a lot to drive down the cost of manufacturing their current and future EVs. Labor costs are undeniably a large part of Tesla's overhead, and if they can really produce future Optimus units for $10,000, that is much cheaper to keep operating than paying a human employee. Of course, there are many implications as to what that means for the future of human work, but in the short term, Elon Musk has talked about these robots primarily replacing the quote, bad human jobs, things that are dangerous, boring, or extremely repetitive. Given the cost benefits, however, it's hard to imagine a world where companies would choose to hire a human for most jobs instead of using these humanoid robots if they can do them at much reduced cost. We'll talk more about the implications of this in a minute, but broadly speaking, using robots could increase margins on these vehicles and allow Tesla to drop prices even further. Even with incentives and tax credits, the cheapest Tesla on the market today costs a bit under $40,000. While Tesla is working on more affordable models and also shifting their focus towards fleet vehicles like the robotaxi, the truth of the matter is that high costs are a primary factor that have slowed EV adoption. Robot employees would do a lot to bring down costs on these vehicles, and these savings could theoretically be passed to the consumer in a major way. In addition to car manufacturing, these Tesla bots will likely be used in the manufacturing of more Tesla bots. That is likely going to be a key element of Tesla bringing down the high price of these robots in time. Highly effective and streamlined assembly lines with little to no human input will be able to cheaply and quickly assemble more robots in record-breaking time. This is the key to enabling Tesla to completing a robot in as little as 30 seconds or 0.3 seconds. As Tesla creates more robots, some of these robots can be put back into the production pipeline and more lines can be created. A robotic workforce can really open up a whole world of possibilities for production, and they are likely to improve exponentially over time, perhaps far surpassing human capabilities. With that said, building up this massive array of robots certainly isn't going to be easy, and it definitely isn't going to be cheap. In order to run a machine like Optimus and have it truly deliver on all the functionality that Tesla has promised, then you need to have an industry-leading AI system powering it behind the scenes. This past year, Tesla laid out their plans to spend $10 billion on training and upgrading their AI systems in just 2024 alone. From there, that expenditure is probably only going to grow even higher as they ingest more data and need more computing power to process it. Overall, there are few companies that are willing, let alone able, to spend that much money right now on building systems like these, especially for these very future-looking products like a robotaxi and a humanoid robot. Even for those companies that have the ability, it will take a lot of time and effort to catch up to where Tesla is at right now, and they may not be able to ever catch up with the automaker's large head start. When you look at their FSD technology and all of the AI training data they have been collecting there, it's something that no other automaker has, and they continue collecting miles every single day on their full self-driving system from tons of drivers. In addition to the AI software itself, you need a lightweight and energy-efficient computer module inside of every unit that will actually be able to run it. Optimus is powered by the same computers that run their groundbreaking AI-powered full self-driving software. Tesla has a lot of experience making these systems since they have been installed in every Tesla vehicle for many years. Having that pre-developed AI computer architecture was a huge benefit for Tesla when they decided to pivot over towards humanoid robotics. These two projects are very intimately tied into one another, and that has allowed them both to advance very rapidly together. At the end of the day, Tesla sees both of these products as solving real-world AI. Regardless of how you feel about robots and Tesla more broadly speaking, the truth of the matter is that these machines are coming. To start, these machines are going to be used in very simple and limited capacities. This is what we have seen thus far with the battery cell sorting robots that Tesla already has in their factories. Soon they are going to be getting better at tasks and be able to replace humans in jobs that are dull and or dangerous. These are the kind of jobs that people don't really want to be doing, but nonetheless they are still income sources for a certain chunk of the population. As their prices come down and their abilities increase, there might eventually be a day where humans are almost entirely phased out of the workforce in this capacity. If humans may someday be far outnumbered by humanoid robots, then in that case, our obsolescence seems all but guaranteed. Naysayers may argue that ultimately robots are just another in a long series of innovative technological breakthroughs that change society but keep humans involved. The automobile may have put carriage drivers out of work, but ultimately, society found new things for those displaced workers to do. There was never a shortage of work to be done, and civilization adapted as old jobs were phased out and technology created new jobs to be filled. This time, however, it is a fundamentally different scenario. These robots aren't just an innovation that will make our work easier. They are set to and intended to replace us at ever needing to do work at all. Work is at the very center of our entire idea of economics. People work to contribute to society, are compensated for that work, and then spend their wages on necessities and luxuries that keep money moving throughout society. Our entire method of commerce is based on the idea that people will have money to spend on the goods that we produce. Having robots that produce electric vehicles, products, and even other robots at record-breaking speeds is great, but not if people don't have money to buy them. In order to produce a robot every 0.3 seconds, you need customers to buy them. If we progress down this route, one where the great majority of people will no longer be needed for their labor, how will that work in society? Some have proposed that automation may generate different kinds of jobs where people are more so used for their mental skills and creativity than just for their manual labor. While this will undoubtedly be true to some extent, it seems that the number of displaced workers will far outnumber the new jobs created. At the same time, companies are already looking at AI to replace humans in creative jobs as well, so it's extremely unclear what will really be left to do. Some have floated the idea of universal basic income as a solution to the impending robotics revolution, including Elon Musk. Essentially, companies would be taxed for every robot that they use that replaces a human worker, and that money would be distributed to everybody equally as a means of sustaining themselves. People are free to work and earn in addition to that basic income, but for those who can't, it would allow everyone an opportunity to live and sustain themselves. This method has its opponents, of course, but ultimately, the best solution isn't entirely clear at this point. It also leads down a whole philosophical path of humans tying their purpose to their work and what that means with that taken away, but that's for another video. The growing field of automation, AI, and humanoid robotics stands to create some of the biggest societal changes that we have likely ever seen. What may have seemed purely science fiction a few years ago is rapidly becoming our reality. Mass adoption of robotics isn't coming tomorrow. However, slowly but surely, it is going to become a part of our lives in a way that many aren't truly ready for. There are definitely ways in which this technology can change all of our lives for the better. Humans may soon be able to dedicate our lives to things that are more personally meaningful and fulfilling than working repetitive day jobs. That's of course assuming that people are not fulfilled in those day jobs, which may not be the case. At the same time, if certain precautions are not taken, we could risk mass unemployment. There aren't any simple answers here, and it will require a lot of action to ensure that this technology does lead to the utopian version of the future that it enables, not the dystopian one. At the center of this conversation right now is Tesla, and they have big plans to carry us forward into this robotics renaissance. It's also clear that even if they don't, somebody else will. We've seen tons of incredibly impressive robot demos from companies like Figure, Agility, Boston Dynamics, and more, so this is coming regardless of who claims the lead going forward. Regardless of where you fall on these topics and issues, some big changes are coming soon. What do you think, though? How much do you think robots like Optimus will start to be integrated into our daily lives? Will Tesla be able to hit these crazy production goals, or is this technology not as ready for game time as some may say? Let me know in the comments below. That's all for this video on Optimus, but if you're interested in learning more about the latest Tesla news, you can check out that video linked up here or in the description below. If you were particularly interested in what we talked about today as well, I co-host the All Future podcast, where we talk a few times a week about things like humanoid robotics, AI, personal electronics, and the future of all things tech. You can find that linked in the description below as well. Thank you so much for watching, and I'll see you on the next one.